All right, so number 20 on, this is the review part, so we're just going to try to quickly go through that. If this is a function, whoops, this is a function right here, and I want to divide it by x plus 3, what is the remainder? So the remainder is the same thing as if I solve this at, x plus 3 equals 0, and got x equals negative 3. It's the same process. If I plugged in negative 3, I would get 8. So that's what the remainder is. That is the remainder theorem. So the remainder is 8. So if it's plus 1, then I'm going to plug in x equals negative 1. And the remainder is right here. So negative 1 is what I plugged in, and I would get a negative 8 out because that is the point of negative 1, negative 8. If I plug in a 1, that's x equals a positive 1. That's the point 1, 8. So my remainder is 8. That's it. That's how that works. This is log, so it's technically not review, but we did do it on the last quiz, so it sort of is, so whatever. Most of this test, I guess, is review. So when we're doing this, we want to state the domain, range, and end behavior of the function. But remember that x plus 3 equals 0, or x equals negative 3, that's your asymptote. So we draw that guy. That's our asymptote. The graph will not cross that, and it will stay on the one side. So if you want to graph it, you need to find some points. Negative 2, 0. Remember, it's alpha window 5 in your calculator to get that base part. 1. So, and then you just plug some you get some points and you plug them in. Remember, when you're graphing, don't go too far and don't ever cross that asymptote. So that's the basic graph of that. The domain, well, it can only, how wide does it get? Well, it's the widest it can get is negative 3, but it doesn't actually touch negative 3, so there's the parenthesis, and then it goes on to infinity. The range is everything. It's how high and low the graph gets, and it goes forever there. And then finally, the end behavior. End behavior is always written as x goes to infinity, and as x goes to negative infinity, what actually is happening to the graph, what's happening to f of x. In this case, we have f of x and y, so it doesn't really matter which one you choose. So this is saying as x goes to the right, so as we're going this way, the graph is going up. It's slow, but it's going up, so if we're going up, that's positive infinity. With this particular one, you remember that it would be going towards negative infinity, going this direction, but we can't go any farther than this negative 3, so that changes this to be a negative 3. So as x approaches that negative 3, the graph goes down. You know, it will be going down farther here. Okay. Factor each. So I am going to just enlarge this so I have some room. So, you know, you're going to keep the f of x, but if I forget it, don't yell at me. So this is just a simple trinomial. Remember, the x to the 4th is the thing. Whatever's there goes on those spots. So minus 4 minus 1, they add to negative 5, multiply to 4. These two are dots. X squared plus 2, x squared minus 2, and x squared plus 1, x squared minus 1. Well, this is the only one that can be factored again. And it is dots again, x plus 1, x minus 1. And all the pieces that you didn't factor need to stay. They should be all in one line, unless it's obvious just because you ran out of space, but try to make it all in one line. So that's that factored completely. This one factored completely. It's 4 terms, so it's factor by grouping. And take out a -4. And we're left with x squared minus 5 and x to the 4th minus 4. So this one can't be factored, so it just keeps getting brought down. This one can, it is dots, x squared minus 2 and x squared plus 2. Those aren't perfect squares, so that's about as far as you can go. Determine if these are odd, even, or neither. It does not say algebraically, so you can just put it in your calculator and see if it's even, it's y-axis symmetry. Odd, it's symmetric through the origin, so you flip it and it's the same graph. And neither is neither. So algebraically, you would plug in the -x. And sometimes we have issues with that. So, you know, right now it's just state whether it's odd, even, or neither. And this one is even. This one is odd. This one is neither. And this one is even. Okay, so then we have a couple work problems. It takes Mary 5 hours to perform a task, working alone. So remember, when we're doing work problems, this side is the alone side, and this side is together. So this is always going to have one fraction on this side, and this side is going to have as many people as you have. And I just made it so I can't erase. So when Steve works with Mary, it takes them 2 hours together. So together we'll go here. Mary's alone, so it goes over here. How long does it take just Steve? Well, that's Steve alone, so that's going there. I don't know how long it takes Steve. That's it. So the common denominator should be 10x. So this one has only a 2, so it needs multiply it by 5x to get to 10x. This one just needs a 10. This one needs a 2x. So now these are all 10x, so they're gone. So I'm left with 2x plus 10 equals 5x, and we solve. Sorry, I was doing the answer there. 10 equals 3x, divide by 3. It's 10 over 3 hours. So it takes Steve, remember, 10 over 3 hours. You can think of this in minutes. It's 3 hours and 20 minutes. So Melanie takes twice as long as Wanda. So Fx is Wanda. Melanie takes twice that. So when they work together, it takes them 2 hours. So together is over here, just 2 hours. But alone, we've got Wanda and Mel. So looking here, the common denominator to me would be 2x. So this one's already 2x, this one needs an x, and this one needs a 2. So these are all now 2x. I'm left with 2 plus 1 equals x, 3 equals x. So this one says it takes 3 hours for Wanda to do it alone, but we want to know how long it takes Melanie. So it's 2 times 3 hours, or 6 hours for Mel. All right, so that's the end. That's the review part, or mostly the review part. Have a good day.